What does it stand for? You're not right. It's not internet.
Oh, wait, no, that's it.
What do you got? Anyone? Documentante.
Infrastructure.
Yes,
Yeah,
infrastructure as a
that's what it is.
service. So there are 4 of those: IaaS, PaaS, which is platform as a service; SaaS, which is software as a service, which IBM is the largest provider of in the world; and FaaS, which is serverless architecture, function as a service. We're gonna do mostly IaaS today, which is hardware. We don't own the hardware. We're gonna provision it in the cloud. So the first thing we're going to look at is IAM rules. So IAM stands for Identity Access Management. So this is how do you secure your infrastructure. So normally you would go in, you would set user, if you on Linux machines, we're not going to look at Windows machines because Windows is, if you can't secure a Windows machine, you have bigger problems. So on Linux, you would go and create user roles. You have to edit files, all this stuff. We can, doing this, provision our machines before they're ever created to have these roles, these users, to have access to them. So there are 3 things we look at. There are other things here, but we won't get into those. The first one is groups. So a group, we're going to name it, we'll call this test.
Is this similar to the Active Directory?
No. Maybe, I don't know.
It sounds like it might be sort of similar.
But so what this is this allows us to create user groups just like you have on your systems and say what should they have access to. And if you search through all this, you'll see all the AWS services, whether they should have read-only access, write-only access, administrative access to each of these services. And then there's also just a global one called administrator access, which is what we'll just use today so that we don't have to deal with anything coming up problems. So administrative access is literally just that. It gives you administrative privileges. It gives a group administrative privileges to any infrastructure we tie it to. So then if we go back to IAM, we can then create a user, and right now Brian's the only one in here, but if we create a new user, this one will be Jared for some reason. And then we can give him 2 things: programmatic access, which means if he just wants to create software to use our stuff, we'll give him that. It'll give him an access key and a secret access key, just like you do with GitHub. I don't know if you've ever done anything with GitHub where you need key. It's like an SSH key, not really, but that's the closest thing I can come up with. And it's just that you can tell your apps how to authorize themselves. The other one is AWS Management Console access, meaning Jared can actually log in and use anything that I give him permission to do. He can spin up new servers, spin up new databases, provision APIs, things like that, and do auto-generated emails. We actually aren't going to do any of this because I don't know Jared's email off the top of my head, and I don't want to go through those dealing with that. So that's how we give people access to creating infrastructure on AWS for us. And then they would get tied to a user group, and the user group in this case was admin access, so Jared would have been able to create and would have been able to spend wildly on my credit card provisioning infrastructure. The other thing we're going to do today is we're actually going to use these. So roles. Roles are how we give security to our individual infrastructure. So when we create a virtual machine, this tells it, when we log into it, what we should have access to on that virtual machine. So we're going to create a new role, and immediately we can see these are the common service roles. We're going to select Amazon EC2, and we'll get all the EC2 related policies. Again, we're just going to select administrative access. That way we don't have to deal with anything, and we're going to give it a name. We'll call this ACM test, which I might have already from the last time we did this. Nope. So ACM test. So this allows us to access anything on EC2. Actually, it's going to allow us to access anything, but because we selected EC2, it says EC2, but we gave it admin privileges then. So that's how we secure our infrastructure. We can say what people should have access to, and what our virtual machine should have access to on themselves. So if I said the only thing we should be able to do is read off a virtual machine, so if I had a database and I said I only wanted the user to be able to read out of my database, instead of securing my SQL database, the MySQL database, I could say only give this user read-only permission for the entire virtual machine that hosts my database. And the only thing they can do is pull out of the table. They can never put anything into the table. So now that we have a role, what we can do is we can actually go into, we're going to look at EC2, S3, RDS, and Lambda. So EC2, this is the first thing. This is virtual machines. So this is how do we create a server in the cloud. So you come in, this is the console. The first time you come in here, you'll see a page. The only option will be create a new instance. I have tons of stuff already open, so I get this special button here, launch instance. But then you'll end up here. Everyone ends up here. So the first thing you'll see is there are SUSE Linux, Red Hat, Amazon, which is a flavor of Debian, Ubuntu, Windows servers, tons of Windows servers actually. Wow, way more Windows servers than I realized. And what we can see is if we go out to AWS EC2 pricing, we can actually see what it costs to run this stuff. So Amazon has a free tier. You get so much infrastructure a month. Let's see on-demand pricing. But the nice thing is if we do Linux, which is Ubuntu, any of the free versions, Ubuntu, SUSE, you can actually get really, really, really cheap infrastructure. You can see we can get a virtual machine with 1 CPU and a half a gig of RAM for a half a penny an hour, which comes out to like $4 a month or something like that. There's a way to make it even cheaper. I forget what the cheaper version of it is, but yeah. So you can get infrastructure really, really cheap if all you want to do is play around with stuff, host small websites, all the way up to things that we can get into some that cost $5 an hour. Those are memory optimized FPGA instances, GPU instances, $260 an hour to do. There we go, $14.40 an hour to do neural networking. So if that's something you're interested in, who is interested in seeing that, it has 64 cores, 64 real cores, 188 virtual cores, 732 gigabytes of RAM. Could you ever imagine using all of that? So in this case, we're going to create a Red Hat server. So the free tier is actually not even the lowest tier. The second lowest, which is called Micro, is actually the one you're going to get in the free tier. That includes 1 CPU, 1 gig of RAM, and up to 10 gigabytes of storage beyond what you use to create your beyond what you use to store your operating system on. So what we do is you can scroll through, see it, all the things that are available to you, or you could sort through what you need. If you get into doing artificial intelligence, you can select GPU, stuff like that. But we're just going to select the free tier. And we're going to hit, so you can instantly hit review and launch, and this will use a default configuration that Amazon has said, or you can hit configure instance details. So the first thing you can do is say how many of these I want. So if you need 100 servers right away, you can say give me 100 servers with this exact crap. And then you also have launch into auto-scaling group, meaning if you deploy, I don't know, you remember from my last talk, I talked about load balancing class. Yeah, this is the class. Load balancing across servers. We can launch into an auto-scaling group, and if these instances come under such 90% load, whatever we say they should, it'll automatically provision new instances into it. So the other thing we can do is request spot instances. So spot instances are really cool. You can get, if all you want to do is like, if you have usually a lot of what they're used for right now are training neural networks. But if you have something you want to do, like in the math profession, they do it a lot too, physics. If they just want to run an algorithm for a couple hours to generate some output, you can actually bid on infrastructure. And if we were to go out and see what the current bid, so Amazon always has infrastructure that isn't being used. That doesn't make them any money. It's costing them money because those servers are running. They would rather have anyone using it than have no one using it. And you can get instances for like 1/100th of a penny an hour. It's absolutely ridiculous. And good instances, not like the small ones we're using now. So you can get really cheap stuff on that. But the problem with that is a spot instance. If Amazon needs that infrastructure, you will get an hour notice and then they remove it from you. So anything you had on it is gone after an hour. So we're not going to do a spot instance. So then the next option we have is to choose a network. So if you know what a virtual private network is, Amazon calls it VPC, virtual private cloud. You could put this into a virtual private network. Generally in virtual private cloud, what you do is you have one machine who handles all your requests, and you have your database on a separate machine and your web server on a separate machine, and then your microservices on a separate machine. And your database, your website, and your microservices actually don't have access to the internet. It's how you secure them. You don't give them direct access to the internet. The only way those pages are served is by a third-party computer, third-party virtual machine that makes those requests and then serves it up. So people can't SSH directly into your MySQL server. They can't SSH directly into your website and get information they shouldn't have. They would have to break through 2 computers to get into it. Subnet, again, that has to do with virtual private cloud, so we're not going to look at it. Auto-assign IP If you wanted to choose your own IP address, you can, I don't. And then we can select our IAM role. So we made it a CM test. That gives us administrative access to the whole thing. And then we have shutdown behavior. So if we want to stop our server, so you only pay while your server's running. If the server's down, you don't pay for it. So if we say we want to shut it down every night, we can say stop. If we know we're going to run it for a couple hours and then we don't want it anymore, we can say terminate. And when we shut that machine down, it'll automatically be unprovisioned and we won't be able to access it anymore. The reason for that is you can only have so many virtual machines at a time under certain settings. So if you're running under the same settings, you might just want to destroy them. Protect against accidental termination. I almost always turn this on. That makes sure when you shut the machine down, you don't accidentally deallocate it if you're running something important on it, like your MySQL server. Enable Cloud Watch. I don't know if anyone remembers Brian's talk about automatic logging systems. Cloud Watch is just a system that automatically puts your logs in the cloud and alerts you when things aren't going properly. You can configure that separately. That's an AWS service, Cloud Watch. So then, tenancy. You have the option here for shared hardware or dedicated hardware. Dedicated costs more. What it means is we only have one core. That means we're going to be on a process. Let's say we have a 4-core processor. We're sharing that processor with 3 other cores that we don't have access to. So we're limited by certain other hardware that it interacts with the processor. So if we do that, if we run on a dedicated instance, we have to change the type we're using so that we are using all 4 cores, or it actually just costs more money and they block out the other 3 cores on a 4-core processor. Shared, it just means we're going to be sharing against other people's thread requests. So then we hit the next page and we get storage system. So by default on Linux, dev STA1 is your system. 10 gigabytes is what we get for free, so we're going to keep it at 10 gigabytes. So then we have 3 types of storage system: old magnetic drives, general purpose SSDs, and provisioned IOPS SSDs. And provisioned IOPS are obviously just high bandwidth hard drives. We're just going to keep it at general purpose because that's in the free tier. Delete on termination, meaning when we shut down our system, this gets deleted. If you get rid of this, it will preserve this, and you can attach it to another virtual machine later. I'm just going to delete it. So we can add tags. I always add 1 tag so that this is my ACM test virtual machine. So when we look at it later in the list of things, we'll be able to identify which one this is. And then configure security group. So we're going to create a new security group. This is where we're going to generate our PEM key also. So we can say what kind of traffic do we want to allow into this. I'm just going to choose all traffic for right now, but you can see there's HTTP, POP3, IMAP, your email, HTTPS, Microsoft SQL. There's all kinds of stuff, and that's just default ports. So we're just going to select all traffic. That way we can SSH into it. We can see, if you didn't know, there are 65,535 possible ports on a computer. That's 2 to the what? Anyone know? I don't know if it's 2 to anything. It's not 2 to anything because it's not an even number. Oh wait, yes it is because it's 0. It is an even number. So custom, we can say what IP address do we want this to be accessible for. So you remember earlier when I said in the virtual private cloud, we can say one machine can access certain other machines. Here we could do this and say that this machine should only be able to receive MySQL traffic from the IP address of our server that is handling the requests. Another way to secure it, we're going to select anywhere, which throws wildcard ports so that we can SSH into this directly. If I were to select my IP, that's my IP address of the computer I am sitting at right now. So right now I would only have access to this machine, to this virtual machine from here. You can rename the security group. I'm not going to do it right now. Oh boy, I didn't want custom mode it anywhere. Yep, I know what that means. So then we just get an overview of what our machine is going to look like. And when we hit launch, we're going to get a warning that says you haven't attached a PEM key. If you don't do this, your thing is not going to be protected. So you're going to create a new key pair. We're going to call this ACM test again. We're going to download that key pair. Okay, good, it didn't complain because I have no room on my P drive for some reason. I can't imagine why I have no room on my P drive. Then when you hit launch instance, that's it. We have a virtual machine in the cloud. We can go back to view instances and we can see this is launching. Oh, it didn't rename it. So now we can see what that is. So while this is pending, we're just going to go out and do something else and we'll come back and look at it. So now we're going to set up a database real quick. This is even easier. So RDS stands for relational. So this is the splash screen I was talking about. If you've never done this before, you'll get a splash screen like this. You just hit get started now. So RDS stands for Relational Database Service, meaning this is a managed service. AWS is really big into managed services. This is Platform as a Service, PaaS, meaning Amazon provisions the hardware for us. We don't have to do it. We don't have to worry about keeping our servers up and running. Amazon will keep them up and running for us. We can see these are the services. These are the databases they support: Amazon Aurora, MySQL, MariaDB, Postgres, Oracle, and SQL Service. These are all SQL databases. Amazon Aurora is supposedly the fastest SQL database you could possibly touch right now when you're on AWS infrastructure, specifically optimized for their servers. We're going to use MySQL because it's free tier eligible. Once again, MariaDB is also free tier eligible. Would appear Postgres. Wow, a lot more than what I was expecting. Our Oracle is also free tier eligible. That surprises me. So Aurora and Microsoft, certain Microsoft products are not. We're going to use MySQL. So it'll show you, do you want to launch this into production? Production costs money, so I always put it into dev because it's not like we're launching this for real. I don't know. You get better performance when you launch it into a prod environment than the dev. Again, remember these are managed systems. We don't get to choose how much RAM we have in the background. We don't get to choose how much memory we have in the background. That got cut off, but it said next step. So this is the only thing, this is the only page we have to deal with. You can choose this to only show options that are available for the free tier if you don't want to, if you want to make sure you don't accidentally spend money. What do we get? I don't know if there's any. Oh, it tells us that if we provision less than 100 gigabytes, but we're just gonna ignore it. So we have an option here. If we were looking at Oracle, we could choose a different license. We can see which version of MySQL do we want to choose if there's a specific one you want to use. T2 Micro is the free tier. So again, that's the size machine we're going to use. They're going to keep that up and running for us. So this is multi-availability zone deployment. And if anyone remembers from my last talk, what an availability zone is, data center. Do we want to deploy this database in multiple data centers? So if one fails, the database continues to run? No, it costs more money. Again, what type of storage do we want? General, IOP, or magnetic? And how big do we want it to be? I'm going to make it 100 gigabytes because that's the minimum recommended. So what do we want to call this machine? We're going to call it test ACM and MySQL. Root. No one knows my password. Who in here knows my password? Raise your hand. Is Jared the only one who knows it off the top of his head? Wow, that's impressive. Okay, so that is not the password. Thank you very much. Oh, it's not. That is not the password. So then we could again launch it into a virtual private cloud if we had one set up, but we do not. So we can name the database test database. Tell it the default port we want it to listen on. And if we wanted to, I don't know how to enable encryption, but apparently we can enable encryption. So then we have backup periods. How long do we want that? We can tell it to automatically back up for us. I don't want it to back up. Again, it costs money. You're provisioning space on a machine, so it costs money. You're going to run out of your 100 gigabytes faster. Minor version upgrades. So if, I don't know if you know, so if you have something that's 5.6.7, 5 is your major version, 6 is your minor, wait, no. 5 is release version, 6 is major update, 7 is minor release. We can tell this to automatically, if they upgrade to 5.6.8, to automatically upgrade for us. And we could tell it when we wanted it to do the upgrade. I'm just gonna select no preference, and that's it. We launched a database. I don't know what that was. We're just gonna pretend that didn't happen. Well, the good news is it's still launching, so it didn't break completely. So we're gonna go back to the EC2 instance. This is the server that we set up before. So this is what you're gonna see now once you put it up. If you hit running instances, you can see all the virtual machines you have provisioned. So we're gonna click on test ACM and we're gonna see a couple things. If we look, yeah.
What is this stopped? Does it still cost money to have?
No, as long as it's stopped, you're not using it.
Okay.
When you launch it, so Amazon keeps an image of it. When you turn it back on, they'll put it into some available infrastructure. Assuming there is available infrastructure, only once in my life have I not had available infrastructure, and that was the day Amazon broke the internet. So we can see all the information related to it, IP addresses, stuff like that. So the number one, yeah,
You never even had a problem during Cyber Monday and Black Friday?
no, absolutely not.
Holy, how much did they overbuild?
No idea. So what we're gonna do is we went to Elastic IPs. So Amazon doesn't guarantee persistence of your IP address unless you make it an Elastic IP, meaning every time we stop our instance and restart it, you get a new IP address. With the Elastic IP, we just guarantee we'll get to keep the same IP address forever, so we just allocated a new IP address. By clicking allocate new address, there was nothing special about it. We'll do associate address, and then we're gonna select an instance. Test ACM, select its IP address, it's gonna be the only one available. And then if this was a prior configured IP address, we can tell it to automatically detach it from the other system and attach it to this one. And we can associate this. So the nice thing about this is if we're running if we have an Apache web server, 2 Apache web servers, and one goes down and we want to move our website to the backup Apache web server, instead of having to go out to our DNS server and changing the IP address there and waiting for propagation to occur across the global DNS networks again, we can just hot swap the Elastic IP over to the backup Apache server. So now if we go back to, how do I get back there from here? Oh, there we go. Instances. And we hit test 8, we click test ACM, we can see now that we have an IP address that matches. So if we hit connect up top, it will just flat out give us the connection string. No one has to figure out how to do SSH themselves. So you can ls, okay. So if you just paste that into a terminal that you have SSH enabled, you can get into the machine. So the problem is, if you read this line here, your PEM key cannot be publicly viewable. So we're gonna do a chmod to get the right permissions on the PEM key. Then we're gonna SSH in, we're in. So we're gonna launch real quick, we're gonna see how fast we can get a web server up and running and get a site up and running. So we're gonna install Node.js real quick. We're going to do this. So the nice thing about this is you're not running on your network connection. We're running on Amazon's network connection, and the better the better the virtual machine we provision, the more bandwidth we get, and you can get beyond gigabit bandwidth. So there are times where you'll download large files and you'll grab them almost instantly on a 2 gigabyte connection. All right, so we're gonna do git clone https clone. Let's see if it works. Of course it's not good. Been having this problem a lot lately with Git. Okay, we're not gonna look at it, I lied.
Is it private?
No, it's a different issue. So, we're just gonna go back. I thought that was gonna be cool, but it's not gonna be. The joys of GitHub. So if we look at our relational database service now and we go back to our database instance. Have a good day, sir.
You too.
We can click this and now we can see all the information about our MySQL server. And if we had something like, I don't have it installed here, but if we had like Data Grip or MySQL Workbench, we could just use this information and connect directly to our database. Now here's the connection string. I don't know off the top of my head. Does anyone know off the top of their head? I bet no one here does. What the command is to connect to MySQL from here. Remote connection to MySQL. Anyone? Didn't think so.
Is it the same as Java?
No, no. It's a MySQL something. But anywho, so that's how we get a database in the cloud. You could, when you're you all have recently used MySQL Workbench, right? This is the connection string you would use here for connect your MySQL connector in Java.
What if you wanted to install like MongoDB?
So if we go back to databases, Amazon does not support wait, Mongo is JSON, right? Amazon only uses DynamoDB, which is their NoSQL database, and it is by far the fastest NoSQL database on their infrastructure. They stopped supporting other ones because theirs were outperforming it so much on their infrastructure. But once again, was built for their infrastructure specifically. So it's tough. It's a tough call, but
Can you still install it through the SSH?
I mean, yeah, if you provision a virtual machine yourself, sure, why not? Not through RDS, but if you provision an EC2 instance, you can install anything you want on it and do what you want on it. So not the last thing, real quick, we're gonna look at S3. S3 is really quick to get through. So S3 is like Dropbox. Anyone remember the application I built? We called it Box Drop. It was the Dropbox clone. Create bucket. So S3, you like your Dropbox? They're called buckets instead of Dropbox. We're gonna call this ACM bucket. Has to be all lowercase. And then we're gonna choose a region. We're gonna use standard. That's where we're at. And that's it. So now we can go into our bucket, we can go to upload, we can drag a file. Let's add a file. So that's my P drive and add something. Oh, there. Start upload. So now this is available for download. If we look at the properties, we need to do two things to make it available. We need to change the permissions so that I'm gonna make it so everyone can open and download it. And I'm gonna save that. And then I can just click this. This is a link I can give to people to download my file. And that's how S3 works. We're gonna see why that would come in handy here now when we look at Lambda. So Lambda is like the way of the future. This is FAAS, function as a service. Yeah, boss.
How does S3 cost in terms of money?
So you get S3 pricing. So you get let's look at it. You get X number of requests. So you get 20,000 get requests per month, 2,000 put requests, and 15 gigabytes of transfer out, meaning when your get requests, not your put, a month for free. And you can store up to 5 gigabytes for free. So beyond that, let's see here. The first 50 terabytes are charged at, you don't pay for, wait, that's per gigabyte request. Okay, so you pay per gigabyte that you're using at roughly 2 cents a gigabyte. Then you have infrequently accessed storage, which it guarantees that your things will, if you make a request for something that hasn't been accessed recently, it could be up to an hour till it's available. And don't quote me on that, but it's an amount of time until it becomes available. Glacier storage is even worse, but it's super cheap. These are stored on really cheap magnetic drives, and the request is like 8 hours or something for you if you want it. You might get it instantly, but it could take up to 8 hours for you to get that. And then you pay per request at a half a penny per 1,000 requests. Oh wait, less than half a penny per 10,000 get requests. So.
Why would they charge more for push, copy, and post?
Less frequent. I don't know, trying to make some money off something that occurs less frequently.
Weird.
So let's look at real quick Lambda. So Lambda is serverless architecture. So here's how it works. So if we want to make a website, we provision, this is why I want to do it, because I want to show how long does it take to get up and running a node website by provisioning the machine, and how long does it take us to get it up and running using Lambda. So what we're going to do is, Lambda is really cool. You write a function, in this case we're going to write it in Node.js, and what happens is when I make a request to the web page that it's going to be linked to, instead of it going out to a server, Amazon stores the function. It instantly pops that function into some available infrastructure it has, executes the function, serves the web page, does the calculations, whatever you want it to do, and the minute it's done running, it deallocates the infrastructure. So you only pay for what are called gigabyte seconds. The number of gigabytes of data you transferred out multiplied by the number of seconds you were running, and the cost is like 0.000000006 cents per gigabyte second. It's really, really cheap. So it's a really fast way to get up and running and a really cheap way to get up and running. And this is what Amazon sees as the future of cloud computing. So how do we do it? We're gonna create a Lambda function. Let's go back, I don't wanna go. So create a Lambda function. And then we have these templates we can use for certain things. We're just gonna choose a blank function. It's gonna show that this is a Lambda trigger. And then we're gonna name this. So this is gonna be called my Lambda function. We have the ability to run it in C#, Node, Java, other versions of Node, and Python. I don't know how to do any of those, so I actually only learned how to do Lambda this past weekend, so we're gonna do it this way. Huh, where's my, I don't know how to serve it in Java. Well, let's see what the, oh yeah, that's way more complicated than the Node version. So we're gonna do it in Node. Except I have a document somewhere that I have the code in, so we don't have to write it.
Wait, what's the Java 8 version?
Hmm?
What's the Java 8 version?
It's just extensive. I don't know. We're not looking at it. I don't want to deal with it. You can go out and look at it. So this is what we're gonna copy here. So we're gonna replace all this. So this is, oh boy, I didn't want to create a Lambda function. I didn't want that. And let's see, can we shift tab back? Oh, look at that. So this is a Node.js function. It uses exports.handler, which is a library within Node.js. Let's not worry about it. If you were to use this template, this is what you would get. It would fill this in for you. All we did was we created var HTML and we fed it a minified HTML. It will only accept minified HTML, meaning all non-necessary white space has been removed, because this is not correct syntax if it was, properly tabbed. And then we use the context object that is passed into the function and just tell it to send the HTML object back out. We're gonna choose an existing role, Lambda basic execution. When I created this, it was just like those roles we created earlier. But this one says, give it access to my Lambda infrastructure instead. We click next. That's it, it just goes back over what we did. What we can see is that we get 128 megabytes of RAM. So again, we aren't doing anything. There's no operating system running behind it. All that's gonna happen is this function can't allocate more than 128 megabytes, which I don't know off the top of my head. What is Java Virtual Machine's default memory allocation? Anyone know off the top of their head? I think it's like 16 or something.
Yeah.
It's something small, so this is a lot more memory. We click create function. So we could test it, but we're not gonna. So what we're gonna do is we're gonna instead serve it up with what's called the API gateway. Now you'll know what a RESTful service is. Rio does, I know that. Right, Rio? You know what a RESTful service is? So a RESTful service is basically, you know what a RESTful service is? I thought you had. Yeah, so basically all it is if I want to know what the weather is outside, somewhere I have a machine that if I type in, let's say the machine is called cumulus.bloomu.edu. I type cumulus.bloomu.edu, whatever port it's running on, /get temperature. And that request goes out to that machine, and that machine sends back a JSON object that has the weather in it. That's what a RESTful API is. It's just making a request to a machine on some port at some address and it returning data back to us. So that's what we're gonna do. We're gonna make a RESTful API that serves up that node function to us, yes.
Does it have to be JSON data or just?
No, we're actually gonna do it in HTML.
Okay.
We're gonna throw away all the JSON because
Usually do it in JSON.
yeah,
or
usually yeah, because JSON is
XML.
the de facto data type, object. What's the word I'm looking for?
Yeah, you're right.
Data type for the web. So that's why it's
It's the
JSON.
smallest.
But we're gonna
most
serve up
efficient.
HTML. So we're gonna do create API. We're gonna name our API test ACM. I'm just gonna click create API, and that's gonna be it. So now we're in here. So what we have are actions, and we're gonna do create method. And you'll see just like on your web page, you have puts, post, options, patch, head, get, delete, any. We're gonna do a get request. We're gonna hit check mark. So then we can see that it's gonna serve up a Lambda function. Wait, something. Oh, I didn't select the region. So once you select the region that we deployed the Lambda function into, you can see a region up here. I happen to know off the top of my head that US East 1 is Northern Virginia. And then you can type it and it will show, oh no, what did I call it, AC? What do we call the Lambda function? Does anyone know? Ah, there it is, my Lambda function. Thank you. 3 points to Gryffindor. And we hit save. So this is saying you're giving this API the ability to invoke that function. We want, when you hit this API with a GET request, it's going to call this Lambda function. But there's two things we have to do yet. we're gonna go to stages. So the first thing we have to do is we're gonna change this from JSON to HTML. Otherwise, what it would do is it would send us HTML formatted as JSON. So what we would actually see is a JSON object with our entire HTML string in it with tags and everything. Instead, we're gonna tell it to render as HTML. Let's see if I can not screw this up. So all we're gonna do is we're gonna put text/HTML here. Hit that. So this is the response object. And we're gonna look at the response integration, which is, what are the codes called? 200, 300, 400, why can't I think what they're called? Response codes, that's what they're called.
Yeah, just response
So what
codes.
we can do is we can tell it what we want to serve. Yeah, shut up, Jared. We want to tell it what we want to serve up on specific response status. Oh, it's right there, response status. So on a 200, which is a success, we want to serve up a document. So what we're going to do is we're going to go down here and we see this is set to application JSON. We're going to get rid of that one. And we're going to change it to add mapping template. And we're just going to change it to text/HTML. Hit enter. Oh, no, not enter. Hit the check mark. And we get this template over. So there's two things we could do. We could actually put our raw HTML here, and it will serve the HTML directly from here. The part about that is that there's propagation time. So it will take time if we want to update our HTML. Sometimes it's pretty quick. Sometimes the other day it took me 5 minutes, 10 minutes to get my updated HTML. So what we can do is we can tell it to serve this special syntax that says serve the root of my Lambda function. And we hit save.
It's using regex.
Huh?
You must be using regex. For
Yeah. I don't know how to do it, but then what we can do is we go to actions, deploy API. We tell it the stage, are you in pre-production, post-production? We're just gonna call this prod, ACM. And you can give it descriptions and tell it other things, but we're not gonna do any of that. And then instantly we get a URL and we can click that. And if it were correct, this was before Rio and I formatted it. Apparently I didn't update the string after Rio and I formatted it. That's how fast it served up a web page. So the cool thing about this is if we go back to the Lambda function real quick, and we look at my Lambda function actions, how do I edit the functions? There we go. We see that these images are being served out of S3. So these are actually things I put into S3. So that's the large use. 4 trillion objects around the world that appear on web pages are served out of S3. That's why when AWS S3 went down back in February, it was such a big deal. There's almost no there's very few web pages in the world that don't use S3.
So S3 is Lambda?
No, S3 was the bucket storage, like Dropbox.
Yeah, so then how does it tie into Lambda?
It doesn't. I'm just serving the source of an image as the
okay.
URL to
Got
the
it.
image in S3.
Right.
So I'm just showing a use case for S3 there.
Nice.
As anyone who was here earlier in the semester saw the other use case I did. So that's Lambda. That's a big emerging technology because it's really, 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 really cheap for companies to use. And they don't have to buy infrastructure. They're only, if one day they have 10,000 users hitting their web page and the next they only have 1, well, they're only paying for 10,001 hits to their server. They aren't paying to run a server nonstop for a day. So then real quick, let's get out of here in 14 minutes. We're gonna look at Watson Conversation API. So this is one I built earlier today.
So to be clear, this is no longer Amazon.
No, so this is no longer Amazon. So this is IBM. IBM Watson, if you don't know, is the computer that won Jeopardy a few years ago. So what I did was I trained this to talk about a car. So immediately you can test your things out here. We'll build one real quick. It says, welcome to the car demo. And I can say hello, and Watson responds back. First thing it does is it notices that this was a greeting. And it says, okay, what should the response to this be? It says, hi, what can I do for you? We'll see how that happened.
How much does this cost?
Free while you're in development. After that, it gets pretty expensive. A quarter of a penny per request. So if you have millions of users using this, every time I type something in here and it makes a request to Watson, it's charging me a quarter. So every 4 requests costs me a penny. Every 4 things I type in here cost me a penny if this wasn't in development. So then I can say, what can I do for you? Play music. What kind of music would you like to play? So the cool thing is I actually trained this to respond to turn on music, but it knows that play is some variation on turn on in this instance, and it learned it on its own that play and turn on mean the same thing here. What kind of music do you want to listen to? It learned that R&B actually means rhythm and blues. So
it has context clues.
yeah, turn on headlights. Okay, turning on headlights. Turn on lights. It learned that lights and headlights are the same thing. You'll also see on the left, it's actually following the tree to determine where in the tree it should evaluate. So you can actually see in real time, no one here is at OPL, but you can see in real time how it's evaluating what part of your statement is true or not.
So this is like kind of nitpicky, but I'm just curious. So like, let's say this was fully optimized for a car, and you said like turn on lights. How would you specify it so that I would know like if you wanted internal lights or like external lights?
We would have to differentiate.
Okay, there would be. You just have
Yeah,
to
so
specify.
we'll look at it. We're just gonna. I'm not actually gonna write this because I'm afraid I'm gonna screw it up because
Yeah.
I literally did this today. So it's like this is the first time I've touched Watson today. Yeah.
Does it know how to do stealth mode?
I doubt that until I train it to do it. Did you have a question? I thought you were gonna say something. We have to train it to do it. Yeah.
Does it compensate for spelling errors?
So yes. So let's look at this real quick. How did we get this up and running? So there are three things: intents, entities, and dialogues. So intents are what do we want it to be able to respond to? These are things I started out with one. It started to learn other things. The cool thing is when Watson, if I were to say something to Watson and it doesn't know, it'll actually save that for later, and I can come back in as the developer and tell it, if it doesn't recognize on its own what intent it belongs to, I can assign it an intent or create a new intent to respond to what my users are looking for. So real quick, this is something I forgot to mention. So Rio and I were having this conversation the other day. What's the difference between TensorFlow, which is Google's AI platform, and Watson, which is IBM's platform? So TensorFlow is made for if we already have large data sets that we want to train our artificial intelligence against, like let's say we're Tesla, who has what is arguably the largest AI set of data in the world. They can plug theirs into TensorFlow and throw their data in automatically into TensorFlow and get output from it. Watson is designed for what we call subject matter experts, meaning I'm really smart at cars. I want to train Watson on my own to respond to people talking about cars. So we're actually going to train it on our own. We're not going to feed it massive data sets of information and have it learn from those data sets. We're going to sit down and our users are going to type out, our test users are going to type hours worth of data. We're going to type hours worth of data, and it's going to learn over time from us talking to it.
Type in crank engine.
That's not going to be on there.
Seriously?
Yeah.
It does not know how.
I haven't trained it to do it.
You have to train.
This has been up and running for, you can see it knows that it's irrelevant. It doesn't match anything it knows. This has been up and running for 2 hours.
Can you import someone else's or like some?
Yeah, so I
template
actually,
into their-
yeah, so I have another one that I actually imported, but it all pretty much does is says hi and hello and how are you. So this is a little more complex. We'll see the tree structure and
Is this technically?
yeah, so I could hit import right here and tell it to import intents.
Does IBM have stuff that can?
They have a
already
couple.
do-
The other one that I imported, but they're really small examples, so it's why I didn't like it. This was the most complex example I could find on IBM, but I had to type it in myself, which sucked.
So they don't have one for like the full English language.
I don't know. I'm sure someone does out there. You can look at it. This integrates directly with Slack and stuff like that, so we could deploy this bot directly out to Slack. So we have greetings. These are greetings I told it I wanted to be able to respond to. These are things I said I wanted to respond to. I need lights, listen to some music, turn on the headlights, play some tunes. Now it recognized play music, which you can see is not in here. Play music is not in here, but it recognized play music as something it should do. It's learning. So we have entities. So entities are basically arrays. So we have an array called genre, and our genres are classical, rhythm and blues, rock, and it's learned that synonyms for these things are symphonic, R&B, and pop. And yeah,
So like, when you said, I forget what your example was with the lights, but that auto-generates as a synonym then? It knows that that's,
Yes, lights is a synonym for headlights, yes.
Okay.
Air conditioning is air, music is radio. Yeah, balls.
Does it just take apart the word that you have and try to find similarities?
So the other thing we have here is fuzzy matching, which is in beta.
Okay.
It increases the ability for it to recognize misspellings and also slang, things like that, like Mernin for morning. It recognizes, and I was testing it earlier to see how far off I could get from the truth.
You have this in development. Do you allow like when you invite testers to it? Do you allow them to like input new things if
Yeah.
Watson doesn't recognize it, or do you want to do development?
So what we'll see is that when we do the test, let's type something completely. Unfortunately, I have this anything else clause down here, which is catching anything that Watson doesn't recognize. But what we will be able to do later is go to here, go to user conversations, and we're probably not going to see anything right now. This populates once a day. So tomorrow it will show me all the intents, everything that matched against these particular things. What we'll also be able to see is things that didn't match anything, and we could create new understandings for that ourselves, or we can assign it to things we've already created. So if I say like turn on wipers, it knows that turn on wipers should be part of the turn on intent. You can see that, right? I just realized pointing it. It knows it's some type of turn on intent, but it recognizes that it has no idea what wipers are. So it tells us I can give you music, headlights, or air conditioning. And later tomorrow we'll see, if we go to turn on, we'll see that there was a mismatch here. And we'll be able to, if we want to, add wipers to our artificial intelligence. It will also learn on its own, given enough time, that wipers is something. Let's get out of this. Crap. Oh.
Can you connect this to like a database? Like if you say, how many people are working today, and you have a database of how many people are working, it will know to go out and get that kind of information. So like it would have like its own API. No.
I would imagine you have to get into the more complex systems they have available for Watson. This is like the really simple. Obviously, we're building AI with a GUI here. Who builds AI with a freaking GUI? So, yeah, I imagine if you go out and look at, I don't have it open anymore. There are dozens of available Watson platforms. This is the simplest one of them all. So if we look at what we have here, we click welcome. What we do is we create dialogue. So this is our welcome dialogue. And we can say, if welcome, so welcome is predefined within Watson. Watson already knows what hello and how are you today and things like that are. We can use these predefined ones. So welcome is a predefined one. And what welcome is it's when we open the chat, it automatically just says something. In this case, that's what welcome is. And in this case, it's going to automatically respond with, welcome to the car demo. So then it automatically, so if we think of this as a tree structure, I wish I could, of course I can't make it smaller. It's a tree structure, flow through. So what we're going to see is welcome happens, and then immediately below it, we get to this greeting. So if we click the greeting, we see that if greeting, and if we go back to intents, remember that this is our greeting intent. We can see these are the things that it can respond to as here. So if the next thing the user says is, anything in our greeting or anything Watson recognizes as some variation of our greeting, then it should do this. It should say, hi, what can I do for you? So then we see the only other option next is, we have two options. We have turn on and anything else. Let's look at the anything else node. This is if the next thing is not some variation of turn on, I want to fall through to anything else and say, I'm sorry, I don't understand, please try again. And the turn on is only a parent node of several other options. Because remember, we have the option to turn on music or turn on headlights, or anyone remember what the third thing we could turn on was? Because I don't know off the top of my head. Doesn't matter. Air conditioning. So we created, the first thing we have is this music. So we said over here in our entities, we created appliances, which is air conditioning, headlights, and music. So if we go back to this, We go back to this. We can see if it matches the music appliance. We want to say, what kind of music do you want to listen to? And then we can see that the music branches off from there into the genres. And if we match the genre, we can say, okay, playing, and then it will match the genre. And remember, now it knows that R&B equals rhythm and blues. So even if we say R&B, it will replace the genre here as rhythm and blues, even though we said R&B. And then true is, so if true means if I make it to this point in the tree, regardless of what the outcome is, and do what I want, do what I said here. I'm sorry, I don't understand. I can play rhythm and blues, rock, or music. Wait, you know what I meant. And the other thing is, yeah.
Can you make that response dynamic?
Yeah, so you can use, that gets more, that's what the @ symbol is.
And then
Yeah, so we can read into users. So it saw that we had this turn on. We said turn on music, and then Watson said, what kind of music do you want? And it expects the next thing to contain some genre, and it will feed genre, whatever you typed in next as the @ genre.
Okay.
So then we can call it using @ genre.
Yeah, because I was wondering, because with your, I don't
Yeah.
understand, you put them all out, so I didn't know if you could dynamic.
Yeah, so the @ is just allows us to, whatever the user entered, @ allows us to access what the user entered.
If you say something like, "Hi, my name is Danny," or something like
Yeah,
that, can
so-
you store a name?
Yeah, so it has built in, so if we go back and we look at intents, we go to create new, crap, how do we get to the predefined intent? Nope, somewhere, or maybe it's under entities, create new, somewhere there are predefined ones. There are things that Watson's already learned, and one of them is recognizing names. Hi, let's say good morning, my name is Brett. Watson says, it is not supposed to be able to respond to this. We can look at the greeting intent. Good afternoon, good evening, good morning, hello, hi. It should not recognize this, but it recognizes good morning. And then it feeds back into its API and says, I know that my name is Brett. And it's hard to tell, I don't know if you can tell up there, but Brett is actually bolded. It recognized that that's our name. It bolds things that it recognizes. And even though we didn't train it to recognize a name, IBM has trained it to recognize names. So we can see that there. If we had the intent, it would automatically assign this to intents. And it would say, good morning and Brett. And it would, if we had implemented the intent, it might automatically say, hi Brett, how are you today? My name is Watson, what can I do for you? So basically all you're doing at the end of the day is just building some ridiculous tree structure. And over time, the more you talk to it, the more it learns to respond to different variations. So it's a really fast way to get up and running. I have no idea how you deploy it. I don't know. They have Cloud Foundry. I don't know. Have you ever heard of Cloud Foundry? It's an API that integrates with things like Slack and stuff like that.
Does Amazon have anything like this?
So Amazon just launched Lex,
Oh, that's right.
which is Alexa. So, and it's pretty much exactly the same.
Whenever we were looking at the tutorials for that, it seemed like
So
it asked you to train, to tell Alexa
So-
to handle things through AWS Lambda functions.
So has anyone seen this this past week's episode of Silicon
I
Valley?
just watched it.
Yeah.
Kappa.
So Kappa. So it's fun. So the AWS must be sponsoring this season of Silicon Valley because they're talking about AWS a lot in it, and they get in trouble in this past week's episode because they had to sell their company because they weren't obeying Kappa, and Kappa is the Children's Online Parental Protection Act. And basically, if your users are under 13, you have to have written consent for them to use your chat applications because they could be chatting with less than savory folk. I didn't want to say the other words on camera. So this says if you're going to put this into production, you have to get parental consent. Amazon automatically gives you API to do that. Otherwise, if you're just doing it for development, you can click no. Literally, this is the first time I've ever walked into this, so I have no idea what it's going to look like on the other side. But what we can see is, it said it before, you can't see it now. I want to type to the bot. Oh, it's still building. So it's training it. So book a car, reserve a car. We can see there's samples. And I'm sure it's pretty much the same as Amazon. I want to test it. Stop building. Maybe if I hit publish. No, what if I hit build? Oh, it's still building. Well, clearly Watson is a little bit faster than Amazon. We got up and running. I think when I built it, I got up and running in like 12 seconds or something like that for it to train to do all that. I mean, I don't know. This might be way more complex, but yeah. So Lex does the same thing that Watson does.
When did they come out with this?
Like 6 days ago or something. I mean, literally, this is brand new. When they launched the Amazon Look, I don't know if you saw that. Have you seen that? So Amazon Look is a small camera device that actually looks at you and AI processes. The AI looks at your clothes and determines whether you look good in what you're wearing.
Forensic nightmare.
Yeah, exactly. Yeah, so it's collecting data on what you're wearing and shit like that. I mean, crap like that. I'm sorry, YouTube users. I know no one swears out on YouTube, so I don't know how this works. I haven't used it yet. Like I said, I only started using Watson today, so I'd say I think it's cool that I was able, having no experience with Watson, was able to get that up and going today.
Should work with IBM.
Yeah, right? I know. That'd be cool, wouldn't it? If they ever call me back.
Totally not sponsoring IBM.
If they call me back, maybe. I'm supposed to start May 15th, and I still haven't gotten an official okay, and I don't have an apartment yet. I have accepted my offer, but that's it. So, any questions? Can we go home? Love you guys. You're all pretty. Thank you, YouTube.
Yay.
No one clap. Just quit.